Hello friends, good morning all of you. Today we will learn about the ETAB, and ETAB software is used to design and analyze the structure. But first of all, you have to understand the difference between designing and analysis of a structure. So, what is designing? If you design a structure, to design a building, then what does that mean? Basically, if you design a beam or a building, then you have to design its component, its member. Like you have to design beam, column, and footing, slab. So, designing means that you have to find out the section, as well as you have to find out the reinforcement in terms of civil engineering. So, you have to find out the reinforcement, as well as you have to find out the section. And what do you understand by analysis? Analysis, that means uh, how much load the member carries, maximum load, and how it behave. Like what's the bending moment diagram? What is the shear force diagram? What is the value of maximum stresses? What's the value of maximum deflection? So that is the part of analysis for design, section, as well as the reinforcement. So this is the basic difference between analysis and design. The second question, that first we have to design or we have to analyze this member. So we have to firstly we have to analyze. We have to find out the shear force, bending moment, deflections, and for that maximum shear force, bending moment, and deflection, we design the member. So that's the basic difference between these two. Now we will start on ETAB. So first of all, this is the basic window. When you start the ETAB, then this is the starting window. So first work, what we do, we will set the units. So in India, we generally use kilonewton, load in kilonewton, and distance in meters. So it's depend on the situation, that the units are given, like architect gives you the units in gibbs, in kilonewton, in newton, in mm. So you choose the units from here. So first work is that unit is in kilonewton and meter. Then go to file and select new model. Then there is the option choose EDB. If you already work on any project, then choose EDB file. Default EDB, that is the default EDB. Now, like I analyze and design a three-story building in which we have one room set. Let's assume one room set. So one room set, that means we have two walls in X direction and we have two walls in Y direction. So we'll set that two walls in X direction. Lines that mean walls or beams. The number of lines in Y direction, that is two. Spacing in like size of the room. So let's assume that a room is 4 by 4, 4 meter by 4 meter. So we'll put the values 4 meter by 4 meter. Okay. Then story dimension. story dimension, as we discussed, that a number of stories are three. Typical story height, that means one is bottom story height. Bottom story height is, let's assume, 3.5 meter. It is generally 3.5 meter higher than the typical story. And rest story is typical story height. So rest story height is 3 meter. You can customize the things from here also. If the story, first story and second story is 3.1, second to 3 is 3.2, like this. So you can customize it. Similar way, in similar way, you can customize grid dimension also. Like you have two rooms and one room dimension is 4 meter and second room dimension is 5 meter. So you can customize the grid. Now, there we choose a grid only structure and depend on the situation. Like when I design for a multi-story building column beam structure, so I choose grid only structure. If I design flat slab, then I choose flat slab. So it's depend on the situation. So in multi-story building or three-story building, I choose grid only structure. Then okay, so that is our plan and 3D views. That is a plan for story 3, and that is the 3D views of our building. 1, 2, 3 story. Okay. So now you can set, this is the plan for third story. So you can choose the second story. Then you can go here, second, first, best story. So you can choose the story plan from here. Then elevation, like this is plan. Then you can choose elevation also. Elevation, this one, A elevation. From this side, if I show the building, so that is this. So in similar way, like now I require third story. Okay, okay. So now you, this is the only geometry of the structure. Like 3 story, there is nothing like this line. This line behave like a concrete now. So you have to assign the property on the building. So first of all, you can define the structure like material properties. First of all, you have to do that. You have to define the structure. First of all, material property. So we go for that. There is already saved three material: concrete, steel, and others. So in concrete, we can check on this, modify the structure. So you can change the value of mass per unit volume, weight per unit volume. Okay, modulus of elasticity, Poisson's ratio. But that is the standard value. You can vary by a small amount. So you can choose the standard values. So that is sufficient material property. So I choose concrete material and I define the concrete material. Okay. Second, we have to choose frame section. So frame section, there are many frame section are there. So like if I analyze and design a concrete structure, so I go for concrete. So I type C. When I type C, then there is also concrete. There is two section, one for beam and one for column. Okay, so I choose concrete beam section and modify and show property. So let's assume the dimension, the section size is zero point 0.5 by 0.5. All units are in meter, zero point 0.5 by zero point 0.5. Mean to say that is 500 mm depth and 500 mm width. In general, that's sufficient. Okay. So select the values depth as well as width for beam. Okay. Next for column. Once again modified this. Let's assume that that is also zero point 0.5 by zero point 0.5. Okay. Now that is the property of section that I define. Then you can also choose the section for wall, slab, deck, plank. I choose slab and the dimension of slab that is given here. That is the basically thickness of the slab. You have to put the values of thickness of the slab. So in thickness of the slab, generally thickness of the slab is 0.15 or 150 mm, 0.15 mm. Okay. Shell member, plates, thick plates. Okay. So we choose plate here. Now okay. So we choose the property of beam, column and slab. Now we have to assign the properties on the beams, column as well as slab. So here it is. We have assign options, and before that, in this vertical column, we can assign the properties of section from here. Okay. Draw line option mean to say that we have to connect 2 points or create a line. That is mean that we can click on a line and that is created. So we will use both of the options so that you can learn how you have to use this option. So first of all, we have to choose here all story or similar story. Similar story mean first, second, third story. All story mean base, first, second, third story. So if I have to draw the lines or I have to draw the beams, so I know that in basement there is no beam. So I choose similar story. First draw line, type of line, frame type, properties, a lateral beam. But we have to choose concrete beam. What property we would create it. So first point and second. First point and second. You have to use second option also, and you will use escape to remove your command. Then second option, that is a create a line. So create a line. Once again, type of line, frame, properties, concrete beam, then concrete beam. So you have to just click on the line and properties will be assigned. So that's the two option that you have to use to assign the properties of the beam. Next, okay, next is column. So create the column. There is option create a column. So create a column. Once again, properties, not a concrete beam, that is concrete column, and you have to select all the area where you have to assign the concrete column. So in three-dimensional structure, you can see that the properties of column is assigned. Now, third one is slab. So we have three option also for slab. We can draw a area. We can draw a rectangular area. Okay, rectangular area, that means we have to connect 4 points and the slab will be created. And third option is very useful, create the area at a click. So we choose this one, properties is slab, and then we have to just click on this and slab will be created. Okay, but the slab is not visible. Okay, so we have to go there, set building view option, and on set building view option you have to click here and show that we want to see object fill also. Okay, okay, so that is our slide. But when you choose this window, the object fill option only seen in this window. So you have to go in this window also, choose the same option, object fill, and okay, I can see the slab in 3 dimensions. Okay. So till now, what we learn how to define a section and how to assign a section. Now, next step, what is next one? Next one is to assign supports. Okay. The supports, we know that supports will be assigned on basement. So we go for basement, plan basement. Okay. Now I have to use only this story, so I choose one story. Okay. So okay, then you have to use story. So you have to use the select object and click here where you have to assign the supports. And when you select all the 4 points where you have to assign the supports, like big supports and support, so then you go for assign and assign joint endpoints. There is 4 to 5 options. So we go for supports, restraint or supports, and then we go for fixed supports. So I assign the supports here. Now next step, assign the load. So you have to assign the load on slab. So once again, you have to go for third story and choose similar story here. Let's assume in general, like code IS 875, the live load is applied on the slab and by an amount of 3.5 kilonewton per meter square. That's enough. So select the slab here and assign the load, shell area load, uniform load, and that is not a dead load, that is live load, that is kilonewton per meter, and around 3.5 kilonewton per meter. Direction is gravity. So you can choose add to existing load. Now I didn't apply any live load here. So add to existing load, replace existing load. If you made a mistake, then you have to choose the replace existing load. But now I've assigned by add to existing. Okay, so it is visible here that is 3.5 kilometer. Okay, so it's a simple structure. Now we have to analyze the structure. We go for analysis, run analysis. 1, 2, 3, 1, 2, 3. Okay, so that is the deform shape of the structure, and the structure carries around 3.5 kilometer per meter square load on the slab. So, but this is the only analysis part. Now you can check the shear force diagram, bending moment diagram, okay, mode shape, etc. From here. This is the output command. Undeformed shape, deform shape, okay, due to dead load, due to live load, what is the deform shape? Then that is for mode shape. Okay, we'll talk about this, but this is our first lecture, so we'll go for basic things. Okay, so there's reaction if you want to check about the reaction. Okay, you can check forces here. Okay, dead load like movement, bending moment diagram. If you want to know about the bending moment diagram, then you can check it. So this is the basic shape of the bending moment diagram. But yeah, you can check the values also. So from here, bending moment diagram, scale field diagram, time here. Okay, show value diagram. So you can check the value. That is the basic diagram for bending moment. Now you can check the shear force diagram also. Shear force diagram. Okay. So you can check shear force, bending moment diagram, reactions. So that is the how you can analyze the structure on ETABS. Okay, this is our first lecture. So it's a basic thing would be required. Okay, in next lecture we will go for dead load, live load, what kind of load on this structure we can apply. Okay, with the help of codes. Okay, so we'll go for that. Okay. Earthquake loads, load combinations, how we can design the structure on for shear for how can we design the structure. Okay, for basic as well as for complex loading system. So thank you very much. Don't subscribe until and unless you understood the things. Thank you.